October 15, 1943, 2:17 a.m. Colditz Castle, Germany. In the depths of Nazi Germany's most secure prison, British Flight Lieutenant Tony Rolt was about to achieve something the German High Command considered impossible. Using nothing but bed springs, razor blades, and stolen wire, he was building a radio transmitter that would crack open the most heavily guarded fortress in the Third Reich. The Germans had stripped every piece of metal, every electronic component, every possible tool from Colditz Castle. They had installed listening devices in walls, positioned guards every 30 feet, and conducted surprise searches 3 times daily. Yet in 12 hours, Rolt would transmit the first unauthorized radio signal from inside Colditz, using equipment so ingeniously simple that German engineers would later study his design in captured Allied technical manuals. But this wasn't just about building a radio. This was about solving an engineering puzzle that had stumped even professional German radio technicians when they tried to recreate it. How do you create electronic components from bed springs? How do you generate radio frequencies using razor blade steel? And how do you hide a functioning transmitter inside a prison where guards could detect the faintest electronic signal? The answer would revolutionize clandestine communications and prove that engineering brilliance could triumph even in the darkest circumstances.
Colditz Castle wasn't just any prison. Built in 1046 on a rocky outcrop 400 feet above the Moldy River, it had been converted by the Nazis into Oflag 4C, a maximum security facility specifically designed to hold Allied officers who had already escaped from other camps. The fortress contained 300 prisoners from 6 different nations, all of them serial escapers who had embarrassed the Third Reich with previous breakout attempts. The German logic was simple. Concentrate the troublemakers in one impregnable location with security so tight that escape became mathematically impossible. But the Germans had made a critical miscalculation. By gathering the most resourceful, technically skilled, and determined prisoners in one location, they had accidentally created what British intelligence would later describe as the most innovative engineering workshop behind enemy lines. German security chief Hauptmann Reinhold Eggers had implemented detection systems that seemed foolproof. Electronic listening devices hidden in cell walls could detect conversations 50 feet away. Metal detectors swept every room daily. Guards conducted head counts every 4 hours. Mail was scrutinized under microscopes. Even the beds were bolted to the floor to prevent prisoners from accessing metal components. Yet, within these restrictions, Allied prisoners had already achieved impossible feats. They had carved escape tunnels through 6-foot-thick medieval stone walls using spoons hardened in illegal fires. They had created false documents so authentic that German border guards couldn't distinguish them from originals. They had built a complete glider in an attic workshop, planning to launch it from the castle roof. But communication remained the ultimate challenge. All letters were censored, all conversations were monitored. The nearest Allied forces were 400 miles away across heavily defended territory. The prisoners desperately needed a way to coordinate with the outside world, to gather intelligence, and to arrange support for escape attempts. That's where Flight Lieutenant Tony Rolt entered the picture. And his solution would be so ingenious that German engineers spent months trying to understand how it worked. By autumn 1943, British Special Operations Executive had lost contact with 17 escape networks across occupied Europe. Without reliable communication links, resistance groups were operating blind, unaware of Allied troop movements, German defensive changes, or coordinated escape timing. The problem was devastating. Traditional radio drops were impossible near Colditz due to intensive German air patrols. Coded letters took weeks to reach London and were frequently intercepted. Prisoner exchanges had been suspended after several communication security breaches. Flight Lieutenant Tony Rolt, a 25-year-old RAF pilot, had been shot down over France in 1941 after 17 combat missions. Before the war, he had studied electrical engineering at Cambridge and worked with experimental radio equipment at the Royal Aircraft Establishment. More importantly, he had escaped from 2 previous POW camps using technical innovations that impressed even his German captors. But Colditz presented challenges unlike anything Rolt had encountered. German Funkabwehr radio counterintelligence units monitored all frequencies within a 50-mile radius using direction-finding equipment so sensitive it could locate unauthorized transmissions within minutes. Any radio signal from Colditz would immediately trigger a castle-wide search involving electronic detection equipment and specially trained technicians. The Germans possessed Telefunken E-52 radio detection units capable of identifying transmitter signatures from component variations. Even if Rolt could build a functioning radio, German technicians would immediately recognize any signals generated by standard Allied equipment. The technical requirements seemed impossible. Build a radio transmitter using no detectable metal components, generate sufficient power without electrical connections, create clear signals without standard crystals or tubes, and hide the entire apparatus so thoroughly that German searches couldn't locate it even when they knew it existed. But Rolt had been studying the castle's structure for 18 months, and he had identified something the Germans had overlooked. Colditz's medieval construction included iron reinforcement bars embedded within stone walls, creating an unintentional antenna network spanning the entire fortress. If he could access these hidden lead veins, he might be able to use the castle itself as a giant broadcasting antenna. The breakthrough came from an unexpected source, the castle's plumbing system. German engineers, focused on preventing escapes, had ignored the fact that Colditz's 19th-century modernization included extensive metal pipe networks connecting every room. These pipes, grounded deep in the castle's foundation, formed a natural radio frequency conductor system. But accessing this network required solving an even more complex puzzle: how to create electronic components from materials that German searches couldn't detect as radio equipment. The solution began with careful observation of seemingly worthless materials. Colditz beds contained standardized Wehrmacht-issue springs made from high-carbon steel wire, precisely wound in coils that could function as radio inductors if properly configured. Rolt's first breakthrough involved understanding the metallurgy. German military springs were manufactured using specific steel alloys designed for durability and flexibility. However, these same properties made them excellent electrical conductors when arranged in calculated series and parallel configurations. Working during mandatory rest periods when guards assumed prisoners were sleeping, Rolt began systematically harvesting individual spring coils. Each bed contained 47 springs. Each spring had 12 coils. By carefully unwinding outer layers while leaving inner coils intact, he could extract radio components while maintaining the bed's apparent functionality. The process required extraordinary precision. Radio inductors demand specific electrical characteristics determined by wire gauge, coil diameter, and winding density. Rolt calculated that 6 bed spring coils, rewound with precisely 43 turns each, would create inductors capable of generating frequencies between 3.5 and 4.2 megahertz, perfect for long-distance shortwave transmission. But inductors alone couldn't create a functioning radio. Transmission required capacitors to store electrical energy, resistors to control current flow, and some method of generating oscillating frequencies that could carry voice or coded messages. The capacitor solution came from razor blades and stolen aluminum foil. Standard-issue German razor blades were made from high-grade steel with precision ground surfaces. By carefully separating the steel blade from its backing and inserting thin strips of aluminum foil between metal layers, Rolt could create crude but functional capacitors. The aluminum foil came from cigarette packages and chocolate wrappers carefully collected from Red Cross parcels. Each capacitor required exactly 0.3 millimeters of separation between metal plates to achieve proper electrical storage capacity. Rolt used threads pulled from his uniform to maintain precise spacing. However, the most complex challenge remained: creating a power source. Traditional radios required batteries or electrical connections to generate transmission power. Colditz had neither, and any attempt to tap into the castle's electrical system would immediately trigger German detection equipment. Rolt's solution was revolutionary. He discovered that human body heat could generate sufficient electrical current through thermoelectric effects when combined with dissimilar metals. By creating a series of thermocouples using steel from razor blades and copper wire stolen from electrical fixtures, he could convert body heat into usable electrical power. The process was painstakingly slow. Each thermocouple generated only 0.05 volts. A functioning radio transmitter required at least 12 volts. Rolt needed 240 individual thermocouples connected in series, each one handcrafted from materials that couldn't be detected during searches. But the real breakthrough came from understanding resonance frequencies. Every structure has natural vibration frequencies determined by its size, shape, and composition. Colditz Castle, with its massive stone walls and metal reinforcements, had a natural resonance frequency of approximately 3.8 MHz. By tuning his improvised radio to match the castle's natural frequency, Rolt could amplify his weak transmitted signals using the entire fortress as a resonating antenna. The castle itself would boost his 12-volt transmission to effective power levels equivalent to a 500-watt commercial radio station. The engineering was brilliant, but implementation required solving one final puzzle: how to hide a functioning radio transmitter that German searches couldn't detect even when they knew it existed.
Rolt realized that traditional hiding places would never work. German search procedures had been refined through months of discovering prisoner innovations. They examined every possible concealment location using metal detectors, electronic listening devices, and physical dismantling of suspicious objects. The solution was distribution. Instead of building one hidden radio, Rolt created a distributed network where individual components were scattered throughout multiple rooms, connected by nearly invisible wire threads run through cracks in medieval stone walls. The inductors were hidden inside bed springs, indistinguishable from original coils unless examined with precision measuring equipment. The capacitors were concealed within book bindings, appearing as normal reinforcement materials. The thermocouples were distributed throughout clothing, sewn into seams and button attachments. But the most ingenious element was the antenna system. Rather than installing detectable metal antennas, Rolt used the castle's existing metal infrastructure. Water pipes, heating ducts, and iron reinforcement bars became transmission lines controlled by nearly invisible tap connections. The tap connections were made from copper wire so thin it appeared to be dirt or stone discoloration. Each connection could be made or broken by moving seemingly innocent objects, a book, a chair, a wash basin, that completed electrical circuits when positioned correctly. German searches couldn't detect the system because it didn't exist as a complete unit until Rolt assembled it for transmission. During normal conditions, the components appeared to be random materials with no obvious electronic function. Only when properly connected did they form a functioning radio transmitter. The first test transmission occurred on October 16, 1943, at 3:42 a.m.
Rolt had calculated that this timing would minimize German radio monitoring while maximizing atmospheric conditions for long-distance communication. The message was brief. Colditz calling London. Rolt transmitting. Please acknowledge. 47 minutes later, a response crackled through improvised headphones made from razor blade diaphragms and copper wire. London acknowledging Colditz. Message received clearly. Maintain contact schedule. Well done. The psychological impact on fellow prisoners was immediate. For the first time since capture, they had direct communication with the outside world. Intelligence could flow both directions. Escape attempts could be coordinated with Allied operations. Morale, which had been declining despite successful tunnel projects, suddenly revived. But Rolt knew the Germans would eventually detect his transmissions. Funkabwehr units were already attempting to triangulate the source of mysterious radio signals originating from the Colditz region. The hidden radio needed to become not just functional, but sustainable under intensive counterintelligence scrutiny. The answer lay in frequency agility and timing unpredictability. Instead of broadcasting on fixed schedules at consistent frequencies, Rolt developed a system where transmission characteristics changed according to environmental factors that appeared random to German monitors, but followed logical patterns known to British intelligence. Weather conditions, moon phases, and even the day's prisoner head count results determined frequencies and timing. German interceptors heard irregular, brief signals that seemed to follow no detectable pattern, making direction-finding efforts nearly impossible. However, the greatest test was yet to come. German counterintelligence had identified Colditz as a potential radio source and was planning the most intensive electronic search in POW camp history.
November 8, 1943. Hauptmann Paul Priem, electronic warfare specialist from German Army intelligence, arrived at Colditz with equipment specifically designed to locate clandestine radio transmitters. His team included 6 technicians carrying the most advanced detection gear available to the Third Reich. The search began at dawn with systematic sweeps using Telefunken radio direction-finding equipment sensitive enough to detect electronic components even when not actively transmitting. Every room was examined. Every metal object was tested. Every suspicious material was analyzed. Rolt watched the search progress while mentally preparing to disassemble his distributed radio network. But something remarkable happened. The German equipment, designed to locate conventional radio transmitters, couldn't identify components that functioned as radio parts only when properly assembled. The bed springs registered as normal bed springs. The razor blade capacitors appeared to be standard shaving supplies. The thermocouple network looked like clothing repair work. Even when German technicians found individual components, they couldn't determine their electronic function without understanding the complete system design. Priem's team spent 18 hours searching Colditz with increasingly sophisticated equipment. They detected the castle's metal infrastructure, the plumbing system, the heating ducts, everything Rolt was using as his antenna network. But because these were normal castle components, German technicians assumed they were not part of any radio system. The search concluded with Priem filing a report stating that no radio transmitting equipment existed within Colditz Castle. His conclusion was technically correct. No complete radio transmitter could be found because none existed until Rolt assembled one for each transmission, then immediately disassembled it afterward. But the close call forced Rolt to develop even more sophisticated concealment methods. He began creating false components that would satisfy German searches while hiding real radio parts within objects so mundane that guards wouldn't examine them carefully. Empty toothpaste tubes became capacitor housings. Broken shoelaces concealed antenna wire.
Even the chess set became part of the radio system, with wooden pieces containing different electronic components that could be combined for various transmission configurations. The network's success extended far beyond simple communication. By December 1943, Rolt's radio had facilitated 3 successful escapes by providing escapees with current intelligence about German patrol patterns, Allied troop positions, and safe-house locations. British intelligence credited the Colditz radio with saving at least 12 lives by warning escaped prisoners about German counterintelligence operations. However, Rolt's greatest achievement wasn't technical, but psychological. The hidden radio proved that engineering ingenuity could overcome seemingly impossible restrictions. Other prisoners began developing their own innovations, creating an underground workshop culture that produced increasingly sophisticated devices from the most basic materials. The network operated successfully until May 1945, when advancing Allied forces liberated Colditz Castle. German guards, who had conducted over 40 intensive searches, never discovered the radio system, despite knowing that unauthorized transmissions were originating from their fortress.
Post-war analysis by both British and German intelligence services revealed that Rolt's innovations had influenced modern clandestine communication techniques still used today. The concept of distributed networks, where system components remained hidden until temporarily assembled, became fundamental to resistance communication doctrine. The thermoelectric power generation method Rolt developed was later adapted for survival radios used by Special Forces operatives. Modern emergency communication devices still use body heat conversion techniques based on principles he discovered using razor blades and copper wire in a medieval castle. Perhaps most remarkably, German attempts to recreate Rolt's radio after the war initially failed. Professional engineers, working with complete technical documentation captured from British intelligence, couldn't achieve the same performance levels until they understood that success depended not just on component design, but on intimate knowledge of Colditz Castle's unique structural characteristics. The hidden radio demonstrated something that modern engineers still study, that innovation thrives under constraints. The more restrictions Rolt faced, the more creative his solutions became. German security measures, intended to prevent communication, inadvertently forced the development of techniques more sophisticated than anything available to conventional military forces. Today, when we design secure communication systems, we still use principles Tony Rolt discovered in 1943. Frequency agility, distributed architecture, environmental camouflage, and improvised components all trace their origins to a British pilot building a radio from bed springs and razor blades in Nazi Germany's most secure prison. The story of the Colditz radio proves that engineering genius can triumph over seemingly impossible odds. When conventional solutions are unavailable, human ingenuity finds ways to solve problems using whatever materials exist. Sometimes the greatest innovations come not from advanced laboratories, but from creative minds working with the simplest tools. If you found the story of wartime innovation fascinating, make sure to subscribe for more untold tales of engineering brilliance under pressure. The greatest weapons aren't always the most obvious ones. Sometimes they're hidden in plain sight, waiting for someone clever enough to see their potential.